Sometimes it's necessary to come up with an approximating function for a more complicated one. For something like this with a curve, that particular function might be really complicated. So if I can come up with an approximating function, that's going to be a lot easier to deal with. And I might be able to get it to within enough accuracy to where I can use a straight line, for instance, instead of a curve. And that's what we're going to be doing here. We're going to be basing our approximating function off of a tangent line, and so this approximating function has a name. It's called linearization. Okay, so that's what we're going to be focusing on here. Now you don't have to just use straight lines for approximating functions. You could also use polynomials, but we're not going to discuss that in this class, but it is possible you could use that. In this case, we're going to be focusing on our straight line right here. So if I take this and I zoom in, what will happen is right where the curve meets the tangent line, we can say that we can use this straight line to approximate a value on the curve itself. So that allows us to work with an easier function. Linear is a lot easier to deal with than a curve. So what we need in order to do that is we have to come up with a linearization formula that we're going to use for these future problems that you're going to see in the rest of the videos in this section. What we're going to use for that, since we're talking about a line here, is we're going to be using the point slope formula, and particularly we're going to use this information from the graph that I drew here. So the A, that's x1, f of A is y1. Slope, we know from algebra, that's going to be your m. So we're going to take this information, we're going to put it directly into here. So I'm going to do y minus y1, y minus f of A equals f prime of A is your m, that's your slope. And then x minus x1, x1 is going to be A. We want to solve for y, so we're going to add f of A to both sides. So when you do that, you get this, it'll be plus right here, f prime of A, x minus A. And then the y, we're going to say that's approximately equal to our linearization function. So we're going to use this in order to estimate values on that particular curve. So L of x is f of A plus f prime of A, x minus A. This right here is called the linearization. And this is the formula that we're going to be using for future problems in this section. What they'll give you is they're going to give you an f of x, and they're going to give you an x value. So they're going to say find the linearization of f of x equals something at x equals something. The x value they give you is going to be the a value you're going to be putting in here, and then we have f of x that we can use in order to find the derivative. So again, this is the formula that you want to use for the rest of the problems in this section.